Hey guys, what's up? I'm here with another OpenCV tutorial for you. We already learned how to detect faces, how to detect a particular object using SIFT and SURF feature detectors, and those are pretty fine. Those are actually advanced, but we still haven't discussed about the basic image processing and color detection and segmentations. So today I'm going to show you how to do a color segmentation to detect a particular object with a particular color. So this will look like this. So let me place all this window in separate positions. So this is the camera view, and I'll be talking about these other windows in the tutorial one by one. So in this code, I wrote this code to detect green objects. So I have a bottle here. So it is detecting this green object. This method is good if the background is not, if the background doesn't have the same color that you want to detect, and it also doesn't work very well in low light. Other than that, this is a very useful technique to do object detection. So here we are detecting raw image, and here we are doing some morphological operation which I will be covering in the tutorial. So this is how it will be. So let's jump into the code. So let's start with a new file. I'm closing this. Like any other tutorial, we need to import CV2 library, import, port, import numpy as np, and now let's define the camera equals cv2 dot video capture, video capture 0, or whatever in your case the id is. After that, let's start the while loop. While let's infinite loop. Okay, so let's grab one image frame from the camera dot cam dot read. So it will read one frame from the camera and it will store in the image variable. Now let's convert that image or resize that image cv2 dot resize. This way the processing will be more faster. 340, 220. You can use any resolution. Now what we are going to do, we are converting the image HSV format, hue, saturation and value. In this format you have hue, you have saturation, you have value. So hue decides what is the color of the image, saturation you know what it is, and value is the how much intensity of that pixel would be. So we need to filter the hue to filter out the color. Okay, so convert bgr to hsv. Let's create another variable img hsv equals cv2 dot cvt color and img. This is the input image, not omg, and cv2 dot color bgr to hsv. So this is the flag that is telling the OpenCV for this method, OpenCV, this convert color method, to convert this image from bgr to hsv. and that's it. It converted it to HSV. Okay, now that we have HSV format, we can filter the green portion of the object. In my case, I'm selecting green because I prepared the color values for green. You can select any other color for, let's say, red or other colors. What we have to do now is we are going to create a filter or called mask, which will only filter out the green portion of the image. So let's create a mask. Mask equals cv2 dot in range. This function filters the range of values that are available in the pixels. So it will, whatever is in the range, it will filter those, and it will allow those pixels, and it won't allow other pixels. So it will be like img hsv is the source image, and we need two boundary values for green. So let's create two boundary values, one lower and upper values for green. uh, let's create a lower bound and a upper bound, a range of values which defines the color green. So I found out these numbers which acts best for green colors. We need to create an numpy array, and the values we are going to use is 333. This is the hue value. 80 is the lower bound for saturation, and this is 40 for the value. And same for upper bound. Let's just copy this, and saturation, I'm going to use the full saturation. Full saturated green image is also a green image, and value I'm going to use full value 255. These are the low. I mean, if the intensity of the light is too low, means in very low light you won't be able to understand which color it is, so it will probably do some mistakes. So that is why I'm going to select, I'm filtering out whenever there is a low light image, and I'm also filtering out low saturation. So I don't want white colors in green, in my green objects, so I'm filtering out whatever color which is lower, whatever saturation which is lower than 80. And now here I am starting from 33, and I am going till 102. This is actually the angle. Hue is calculated based on angle, so from 33 to 100, 33 degree to 102 degree, this range consists green color in the hue. Other values, the saturation and value, you can make it constant, and you can change this hue value to switch to different color like red or blue if you want. Okay, so we have created a lower bound and upper bound. Let's put them in the range. Lower bound and upper bound. Upper bound, let's copy and paste it here. Let's put it, put a comment here. Create the mask. Now if we test it now, we will see that it will be able to detect green objects. So let's test it. cv2.im show. We are going to show the mask, and we need to give a wait key of 10 millisecond will be enough. So let's test it now. We have to save it in desktop, color seg something, require matte position. Oh sorry, here we have to provide the name of the window. Let's name it mask, and let's test it again. So this is the mask. Okay, let's put the original image also side by side. Copy, paste. This is cam, this is img. Let's run it. So this is the cam, this is the mask. Now you can see there are some noises. It is picking up some values randomly. I haven't placed any green objects, still it is placing. Some of the pixels are getting passed through the filters, which we'll be dealing with later. And if you see this, here it is totally allowing the green pixels in the mask. So that is this object we want, and we can see some these noises. Let's remove those noises. Let's stop it. Okay, so we have created the mask. Now what we have to do, we have to do some morphological operation or noise removal. Okay, so if we see this, we are going to use two methods called opening and closing. What opening does, it creates, first we create a kernel, which is basically a area or box. You can say this is one kernel of some height and width. This will go, it will scan the image by sliding this window in the entire image, and whenever it finds a white pixel, which is a group of white pixel which is smaller than this kernel, it will remove that image, that pixel, that group of pixel. So this is opening, this is called opening, like this. But it will not remove this group of pixel, because this group of pixel is larger than the kernel. So this is called opening. So that way we can remove all these noises. So let's see how it looks in the code. So let's name the new mask open equals cv2 dot morphology x mask open, and cv2 dot morph morph open. So this will do morphological operation, and it will cv2. And we need a kernel, and the kernel size will depend on the image resolution. So in this case we are defining the kernel size to be 5 cross 5. Kernel equals kernel open. We can create, you can select same kernel for opening and closing, but in my case I am selecting two different kernels because I want the closing to be more effective than opening. So it will be np dot once and it will be two brackets 5 comma 5. So I'm going to use this kernel for opening, and let's first test this, then we will move forward to closing. Let's copy this, copy, paste, mask open, and let's name it also open. Put it in, let's create some gas in between, and let's run it. Mask open is not defined. Mask open, sorry, this will be the input source image. Now let's see. Module has not morph open cv2 dot, okay, morph will be morph. Okay, though those are some typos. So we have it. This is the raw filter, and after opening we get this, we remove those noises from here. So why do we need closing them? We already removed the white noises, so let's see why we need that. If you now see this object, you you will see there are some dots in between these white objects. For the, to clear that portion, we need closing. What closing does, in closing does exact the opposite of opening. We have a kernel, and whenever there is a group of black pixel which is smaller than the kernel, it is filling the holes. So whenever it will go all over it will scan all over the image, and whenever it finds one black hole, it will close that. So after closing, we will be able to close all these holes in between, small dots, black dots, everything. So it will look more smoother and cleaner. So let's see how after closing how it looks. Let's close this first. Okay. So let's use the closing, which is mask close equals cv2 dot same thing. So let's copy it. In this case, we are going to close on this image, not in the mask, because we already removed the noise, and after that we want to process further. So it will be in the input will be this image and then the close. So this portion will be close instead of open. close close, and we can use the same kernel, but let's see how it looks first. Then we will decide. Let's copy it, paste, and close. And this window name, let's name it close. Let's see. So this is the original camera, this is the raw mask, this is after opening, this is after closing. So let's see with that object. Now you can see there is no holes in between, but we can still see some larger holes that are coming sometimes. It is trying to close that hole, but still it is getting. That is why I'm using a larger kernel for closing. If it is a the object is further away, then it's fine. But when it's okay, we can stick with that. Or else we can create a close. Let's try another kernel. Let's create another kernel here. Copy it, paste it. Let's make it 20 cross 20 and name it kernel close. So this will close larger holes. So you can try it. So this is the object, and now you can see that it is almost closing the holes. And we can also see that there was a breakage here previously. It was there was means gap here. Now this is filling that gap also. So I think it's fine. We can use this as a green object detector. So let's identify and mark that object. We want to mark that object in our original image. We want to point that out the where that object is. So let's do that. So we have our mask. Let's name it final mask. Mask final equals this one. This is for just if we want to do for some further operations, so we can do it in between and then we can work with this final mask. We don't have to change the variable names again and again. We have the mask. What we have to do now is detect the contour of that white object. So we have a method called cv2.findContour, which will return contours and the hierarchy format of that. If there are multiple contours, it will return the hierarchy of those. Find TOURS, find contours, and let's put the final mask here. And what I am going to do is I am going to copy it, because find contour will destroy the original image. So I am going to use dot copy, which will create a copy and send it to the method. So the original original image will be same, original mask will be same. Now we have some flags. These are basically we are telling the method what we are telling the method how the hierarchy of the contours will be decided. So we are going to use ret external and the approximation. We are going to use cv2 dot chain approximation. These are two flags which we will need for this method. And now we have the contour in this contour variable. So that's it. We can now draw this contour. We have a method called draw contours, and the image in which we want to draw the contour, which will be the original image, and the contours. This is the contours that we found from the mask. And now we want to give the color, which will be 0 and whatever color you want. This is in format of BGR. So first one is blue. Let's create a blue contour. So this would be a blue boundary of around the object, and we want the thickness. Let's make it 3. So this way it will draw the contour and we will see it in the original image. Let's test it. We have the original image, we have the raw mask, and okay, we haven't displayed the final mask, but that's not necessary because we will see that image, that contour in the main image. So we can see this is the final mask. Okay, now we want to place a rectangle over the entire object. So let's place a rectangle. Let's close it. So to put a rectangle, we have to loop through all the contours that it has detected. So for For that we need a for loop for I in range. Now how many contours are there? That is the length of the contour list cons. So we are going to loop through the contours. Let's create a boundary for the contour so that we can draw a rectangle over it. It will be x, y, width and height equals cv2 dot bounding rect. If we use this bounding rect function, it will give us the coordinate, the initial position of the contour and the height and width of the contour. We can easily draw a boundary on the contours now. So we got the bounding rectangle and let's draw it. cv2 dot rectangle and we want to draw it in the original image, and the starting position will be x comma y, the height, the ending position will be x plus w, which is location plus width, and y plus height means y root plus the height of the object. That will be the end of the rectangle, and we want to detect the select the color. Let's make it green, or let's make it red. 0 comma 0 comma 255, and now we need the thickness of the line. Let's make it 2. So we have rectangles, and another thing I want to do is I want to put a number of that object, that what is the order of that object. If there are multiple objects, so it will show 1 0 1 2 3 like that. So for that we need a method called put text. We are already using it in our other tutorials. cv2.cv.put text, and we have to define cv2.cv.from array, and this will be the source image. And we want to next we want to write the number of that object. So it will be the index. So it will be for first image it will be 0, second image it will be 1. Let's make it 1 I plus 1, so it will start from 1 instead of 0. And then the position of the text where we want to display the text. So let's make it at the bottom left corner. So it will be x will be the left corner, and the height means y plus h will be the bottom position, and we have to define the font. So we haven't defined any font yet, so let's define a font equals cv2.cv.init font. Now cv2.cv.cv font underscore HERSHEY. This is the font I'm using in most of my tutorial. Here, simplex. And these values will define the font size and thickness. You can check it in my other tutorials and or my blog what are these values. I'm currently not sure which one is which. You can check that later. So let's set the font, and let's set the color, which should be 0 comma 0, and we used blue for the contour, red for the bounding box, and let's give yellow for this text. So to make yellow, we don't have yellow, we only have BGR blue, green, red. To make yellow, we need green plus red, I guess, if I'm not wrong. This will create a yellow text. Okay, so that's it. Let's run this and test it. I hope it won't show any error. Okay, there's no error, thank God. Uh, so we have our four. Okay, we have an error. What is the error? Points to an array, neither a scalar. Okay, so it will be the contour, not the list of the contour. So we are getting the current contour, whatever I am looping through, whatever in the current loop we are working on. So it will be cont of I. Sorry for that. And let's run it again. Probably there are not. Okay, so there are no errors. Don't have any errors in. So you can see that if I place my hand here, so it becomes two separate objects. So it is defining the first one, this is the second one, and if I remove my hands, it's a single object and it is defining it as one. So that's it. Thank you guys for watching. I hope this helps you. Please give a thumbs up and hit the subscribe button. I'll see you in the next video.